Welcome to solverfy.
Question number 109 is an extremely challenging question that I'm moderately surprised to see in a general chemistry textbook. It takes into account some acid-base chemistry principles, some hydrodynamic principles where we have a flow of water through pipes at so many pounds per hour, and then a whole bunch of different unit conversions. We have in the water stream a strong acid, sulfuric acid, at 10 parts per million, and then the weak acid, acetic acid, at 0.015%. So in addition, we have to, with our unit conversions, convert parts per million and percent by mass acetic acid into something more manageable like molarity. So let's begin. We have 10 parts per million sulfuric acid. So let's take the 8.0 times 10 to the 3 pounds of water that pass per hour. We won't need to worry about the per hour part because the entire question is in reference to the pounds of sodium acetate that we need to add per hour. So we will just take the pounds of the water stream per hour and use that as our reference. So if we have 8.0 times 10 to the 3 pounds of water, we can convert that into grams of water and then go from grams of water to grams of sulfuric acid using the part per million definition. If we have 10 parts per million, we have 10 grams of sulfuric acid per million grams of water. Then we can convert the grams of sulfuric acid into moles of sulfuric acid. And this is where we will begin. We then have, in 1 hour, with 8,000 pounds of water passing by with a 10 ppm concentration of sulfuric acid, we have 0.370 moles of sulfuric acid. Let's do the same thing with the 0.015 mass percent acetic acid. We'll take our 8,000 pounds of water passing per hour, convert it to grams of water, and then convert the grams of water to grams of acetic acid using the definition of 0.015 grams acetic acid per 100 grams of water. Then we'll convert the grams of acetic acid into moles of acetic acid, and this is how many moles of acetic acid that we would have present in the 8,000 pounds of water. Okay, what we now want to do is we want to figure out how much of the weak base sodium acetate trihydrate needs to be added in order to maintain the pH at 5 or greater. So the first thing that we need to recognize is because H2SO4 is a strong acid, not just the first hydrogen, but the second hydrogen is pretty strong too. It's even stronger than acetic acid. That we will need to add 2 moles of sodium acetate for every mole of H2SO4 in order to make 2 moles of acetic acid. So what I'm considering now is converting all of this into acetic acid by adding some sodium acetate trihydrate. Then I will add an additional amount of sodium acetate trihydrate once I've converted all of this into acetic acid in order to create the buffer at pH 5 of acetic acid and sodium acetate trihydrate. So the mass of sodium acetate trihydrate that is needed to convert all of this into acetic acid based on this chemical reaction will simply be equal to the moles of sulfuric acid that I have, recognizing I need 2 moles of acetate for every 1 mole of sulfuric acid. And then this will give me moles of the acetate required. I can then convert the moles of acetate into grams sodium acetate trihydrate by using the molar mass of sodium acetate trihydrate. And I get 100.7 grams of sodium acetate trihydrate. Now what that did is it would convert all of this into acetic acid, but I still haven't made my buffer. So in order to prepare the buffer, I need to add more sodium acetate trihydrate. And I want my buffer to have a pH of 5, so I'll use the Henderson-Hasselbalch equation. pH is equal to negative log of the Ka value to get my pKa. The Ka value of the weak acid present is acetic acid, with a Ka of 1.8 times 10 to the negative 5, plus the log of, I'm going to have moles of my base, acetate, over moles of my acid, acetic acid. The moles of the base, I don't know. That's what I need to figure out. The moles of my acid is going to be equal to the moles that was present plus the moles that I just made by converting all of this into acetic acid. And for every mole of this, I make 2 moles of acetic acid. So that's why I have down here for my moles of acetic acid, the moles I start with plus 2 times the moles of sulfuric acid, this now corresponding to the moles of acetic acid that came from sulfuric acid. Then I finish my algebra and I get X equal to 17.64 moles. So this is the moles of the additional moles of sodium acetate trihydrate that I need to add on top of this mass that I just added to convert all of this into acetic acid. So the total amount that I need to add is going to be the 17.64 moles converted to grams by multiplying by the molar mass of sodium acetate trihydrate, and I get 2,400.5 grams. But that is the second amount that I need to add on top of this amount to get all of my sulfuric acid into acetic acid. So the total amount will be the sum of those 2 amounts. But it doesn't want the mass in grams, it wants the mass in pounds, of course. So once I sum these together to get the total mass in grams of sodium acetate trihydrate that I need to divide it by 453.6 grams to get pounds. And I get about 5.5 pounds of sodium acetate trihydrate that is needed per hour to keep the pH of 8,000 pounds of water containing 10 ppm sulfuric acid and 0.015% acetic acid at a pH of 5 or greater.